Walter Baade, born 1893. He was studying the Andromeda Galaxy, another galaxy, the closest one to the Milky Way, but it's still far away, but it's the closest galaxy. He was studying it, and there he was seeing two stars. He was studying them. And these were Seyfert variable stars. So stars which are getting brighter and dimmer. They are varying in size. They're getting brighter and dimmer. Now, and they're doing that in fixed periods. They're doing that between some days and a few days. Maybe one takes 5 days, maybe one takes 50 days. So it gets brighter and then dimmer. And a person on the Earth can just look how long does it take to get brighter, 5 days, and dimmer 5 days. And now it's 10 days for one period. And it is possible to calculate now how bright the star is, just because of knowing how long the period was. If it was, the longer the period is, the brighter the star is. So it's possible with 10 days to say it has this brightness. If it's 20 days, that brightness, 30 days, that brightness. So from that, through observing how long the period is, it is possible to know how bright that star is. A star is bright, but on the Earth it is dimmer. A star is a sun, so the sun on the Earth is a very bright star. It's very bright from the sun. The other stars are very much darker. In the night, even in a starry night, the stars are giving basically no light at all. But these are all just stars, so there's these suns. All these suns in the night sky, in a starry night, are all suns. They are very bright, but on the Earth only a little bit of a light appears. It is not possible to look now how bright such a star is now on the Earth, how bright appears it. It is actually much, much brighter. It's just very, very far away. So it is not possible to look by such a Seyfert variable star, how bright appears it on Earth. Just very, very, very dim. If at all with a naked eye, very dim. But we know from calculating how long the period was, 5 days, 10 days, how bright it actually is. And now by comparing this, how bright appears it on Earth, just very, very faint, and how bright is it actually, because we know how bright it is, because the longer the period is, which is getting brighter and dimmer, makes how bright it actually is, how far it is away. So we can calculate how bright it is, because we know the period to get brighter and not so bright, and we can measure how bright it is on Earth a little bit faint. And now we have the distance. Walter Baade did that with 2 stars, and he found out that the Andromeda Galaxy is actually double as far away as believed. The star previously used wasn't completely proper, or the assumption wasn't completely proper. He found out the Andromeda Galaxy is 2.2 million light years, 2.2 million something away. And so this is double as much, and then other distances in the universe were as well recalculated based on it. So Walter Baade was studying the Andromeda Galaxy, 2 Seyfert variable stars, how they're getting brighter, how far they're actually away, calculated it is actually double as far away, and all the other things were also recalculated. That is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1. Book 1, Part 1, Structure of the Universe, written by Ian Ridpath and John R. Shakespeare on the page 50.